Video is recording. Thank you. Okay. So in the last class, we have seen the we have started module 6 and we have seen a problem, and in that problem actually I was discussing earlier on in terms of angles, but it requires only that the thing is, I will just briefly tell you that uh, there was a hill and there was another small hill. Okay, the problem was given and this distance was given. Please note down. This distance was given 40 meters. This was given as 16. This was given as 26. Immediately after getting from the class, I sent you that solution. Okay, just to explain that, the problem was that what will be the velocity from here, so that means if it is thrown like this, then what will be the velocity here, minimum velocity, so that it will cross this, it will pass through this point. Okay, so the thing is that the idea is, that means from this point to this point, when it falls up to this point, it should travel at least this. That is the concept. So from that point of view, it will be simply rectilinear translation. Okay, so this height is 10 meters. So if I write in terms of y, so what is the initial velocity? Ux is equal to u and uy is equal to 0. Initial downward velocity is 0, right? Initial downward velocity is 0. So here, since it is being projected horizontally, so initial vertical component of velocity was 0, uy was 0 and ux was u simply. Now this distance is minus 10 meters. So if I write in terms of y is equal to u y t minus half g t square, because g is in the negative direction, so minus gt square, and x is equal to uxt. These are the two solutions. These are the two things that we have to solve. Now this is ut, because ux is u and this is 0, therefore I can write that minus half gt square. Note of this. Okay, clear? Any question? Top একটা মানুষ দাঁড়িয়ে আছে. He is throwing a stone from this hill so that it will cross this hill. Okay, now as it crosses this, remember that this is a curvilinear translation. Curvilinear translation in space. Therefore, the problem is how to make the stone cross this hill. That means when it will cross this hill, it has to travel this much of depth. So when it crosses this much of depth, it should travel this much of length. That is the problem. At the same time, when it falls, it will cross that much of length. Okay. So I have written these two simultaneous equations in terms of x and y. Now I know this is 0, so it will be minus gt square. Right. Now you see that this is clearly known, but this is unknown. So I will first solve this one. Okay. So for this, y is minus 10 because it is in this direction. Because I will take y in this direction positive and x positive in this direction. So it will be, if I write minus 10 is equal to minus half gt square. Therefore, since t is unknown, I will solve t. T is equal to 20 by g root over. That is, g is 9.81 meter second square. Okay, and therefore, what is x? X is this much, 40. So, in this equation, I can write 40 is equal to u into t. T is this much. Because these two happen simultaneously. That means during this time it falls minus 10 meter and it travels 40 meters. So there this t is common. So 20 by g. Therefore you can solve for u. Okay, you can solve for u. So u will be 40 under root g by 20. You just put the value of g is equal to 9.81 and you will get the answer. So that will be in second. Okay. Meter per second. Right. Meter per second. Clear? Okay. So today I will start a new topic. There will be so many topics we will discuss. In this module 6, I will discuss basically problems which are in application and it is related to also theory. But mainly we are targeting problems. Okay, is it done? So that it is under module 6. Okay. So similar problems will come. Similar problems will come. Also, please try to remember the conceptual questions that I usually ask. Okay, like say, what are the assumptions? Like here we assume that drag is 0, right? Also we assume that g is constant, right? We are taking g as constant. Otherwise, we have to integrate for g also. We have to take g as a function of position. G as a function of position. As position changes, g will also change. So from that gravitational that part we have to introduce. Otherwise, here we are considering that gravity is constant. Acceleration due to gravity is constant. So these kind of conceptual questions I used to ask in my questions, in my exam papers. Okay, but university has their own kind of questions, so they may match sometimes. Like last time there was a question like tensor flow, but that is not means related to your syllabus of tensors. Okay, so they may do mistakes and you have to suffer. Okay. Or what you can do is you can write to university after the exam that this was out of syllabus. Last time there was two questions in CA4. Okay, be careful. Last time there was two questions in CA4, although these were not there in the syllabus. Okay, one was in from virtual world, another is from vibrations, theory of vibrations. Okay, please don't play with mobile. Roll number 79, the 69. Okay. Uh, okay. So, two questions were there. One is from actual world, another is from vibrations, but these were not there in the syllabus. But if some questions I can discuss, then I will discuss after I complete the prescribed syllabus. Okay. So today I will discuss one topic which is related to uh, motion or rotation about a fixed axis. understood? Okay, you can come from the next day. You have to come in time and do not ask me. Okay, from the next day come, but do not ask. I did not tell you to leave, but you have to come in time, and you please do not ask me. You just come. Okay. Yes. Recording. Okay. So please be quiet. Okay. So that we can continue smoothly. Now fixed axis rotation. It is in plane. So 2D. In 2D. Okay. Module 6. It is a part of module 4 also. But as a problem we are discussing in module 6. Okay. Because in module the topic is close, there is common to module 4 and 6. This is not mentioned in module 4, so I am discussing in module 6. Okay. Okay. Now consider that there is a general object, not a particular set, general object, which is okay. So this is a general 2D object which is rotating around this point, which is O. Okay. There are some forces acting on this. Today we are going to discuss a very important topic. Please. Today we are going to discuss a very important topic. At the end we will understand what is the importance of this. So please let me please cooperate so that we can complete by 3. Okay. After that we will have enjoyment and all. Okay. Okay. Say there are some forces. 1, 2, 3, maybe n. I'm showing 3. Okay. And also there will be one force which is due to acceleration due to gravity. That is weight. There will be one force. So I'm showing some point G. Some point G. This is G. And this is the weight. Okay? Now this is the condition, force system, whatever is there. Now immediate task is what? Immediate task is to show the free body diagram. Okay. So we will draw the free body diagram, corresponding free body diagram. So here please don't talk. As if I am drawing the same object without this support. So as if this is the same object without the support, these forces will be there. So I am drawing these forces. F1, F2, F3. Then we have G here. So G. And what else? Here there is a pin joint. So for a pin joint, it can resist a movement of this in this direction and movement in this direction. Okay, so accordingly we can show them. Now here it will be a rotation. For example, it will be a rotation. So I have to understand that in this there will be two components of the reaction force. One is if it is along x direction or along y direction, or can be along the tangential direction and normal direction. So depending on the choice of coordinate system, we can show either in the x direction, y direction, or in the normal direction and tangential direction. Since for a rotation, radial and circumferential or normal tangent will be a convenient choice. So it can be both xy or normal tangent. So I am showing in terms of normal tangent. So what is the normal tangent? O. First let me draw point O. So this is O and this is G. So I will connect these two. This is the line. Therefore, normal is towards this. Normal is towards this. So I can write R N normal. Normal component of the reaction. Another is tangential. I do not know whether it may be the object will be rotating in this direction. So omega maybe in this direction. So accordingly, the tangential component is perpendicular to this direction. So this is tangent and this is normal. So accordingly, we will have a normal reaction towards this. Towards this. So I can write this as R T. Okay. So this is called the free body diagram. Try to understand that whatever forces were there, this one, this one, this one, and this one we had considered. Along with that, since I have replaced this with the support corresponding reactions, I have to incorporate. So that is a complete free body diagram. Okay. Now, sometimes it is convenient in dynamics problems that also we understand what is the resulting effect. These are the cause. So force, as I have mentioned in the first class of mechanics, that forces are the cause and motion is the effect. So in mechanics problems, what we do is from this we have got this. Now what we draw an equivalent diagram that is called kinetic diagram. Okay. So what we do is, as we know that for this situation of these forces, there will be a corresponding motion. The motion is here G and O. This is O, this is G, and this is the line connecting OG. So we know that for this kind of system, rigid body, under this force system, there will be two motions. One is the linear translation, another is the rotation. So if I consider this, so there will be a motion which is in this direction, since it is so. For a rotation, I am showing it. It is m mass of this m into a. A means acceleration of the center of mass. So I will do with a bar. Acceleration of the center of mass, and it is in the tangential direction. So the component, this means A, please. This means A bar means the component of the acceleration of the center of mass in the tangential direction, and another will be M A N. So this is the component of. So what is that? I know that I am writing the corresponding equations. So I know that sum of all forces means all forces. This. cumulative of all forces, okay, is equal to mass into acceleration of the center of mass. That is called the Newton's general law of motion or Euler equation. Euler equation of motion. For a rigid body, this is called the general Newton's law of motion or Euler equation. Okay. So, as we have discussed earlier, so this is the motion equation. This is the motion of the center of mass. So I can decompose this into mass a t plus mass to a n. So we have two components of this that I have shown here. Okay. Next is what? Since there is a rotation, therefore what we do is I can write that sum of the moment of all forces about point G is equal to Ig alpha. কি ভাই কথা বলছেন কে? এত কথা কিসের? Sorry, sir. Okay, thank you. Okay, because I have to complete this topic today only. Otherwise, it will not be it will be complicated. Okay. So you see, this equation is for the rotation and this is equation for the translation. So this is for translation. This is the try to understand. In this type of problem is hidden the solution technique for the dynamic problems. Okay, once you grab this, it will be easy. Translation of the okay. I am requesting you because only I know that at the end of the course you have a huge syllabus to face during the examination. So be careful, be attentive. If you have any doubt, you can ask. Otherwise, you will see that the classroom situation and the exam situation is completely different. You will see the questions. So try to be serious. Okay. Now this is what? Since I am calculating the moment about the center of mass as if I am trying to understand the rotation about the center of mass. So translation of the center of mass and here rotation about the center of mass. Okay, these two equations simultaneously, because for a rigid body, when it is subjected to forces, it will not be only translating, it will be rotating, right? Because at different points you may have different velocities. So for a translation, all the points are having the same velocity. But for a rigid body, there may be a possibility that all the points are having different velocities. Therefore, it will be rotating at the same time translating. So since both are happening simultaneously, both equations are available this way. So I am showing here. Now the translations I have shown. Now I will show the rotation also. So rotation depending on the direction of alpha, it is the direction of omega. But alpha can be in the same direction, that means it is accelerating, or it will be in the opposite direction, that means it is retarding. So acceleration means alpha and omega are in the same direction, and retardation means omega and alpha are in the opposite direction. So without knowing the values, I cannot tell you that in which direction alpha is. So I can generalize that it may be in this direction or in the opposite direction, alpha. Okay. So in any way, say I am showing, say a rotation about this. So this is summation of all forces. That means this is the sum of moment of all forces. Therefore, it will be Ig alpha. Ig alpha. So this is called the kinetic diagram. Okay, this is the kinetic diagram. Now Now you try to understand. I am now separating the kinetic diagram for understanding. Now you see that here this is point O, this is point G, this is point G. Now along this direction I have one force M A N, and in this direction I have another force, that is M A T. Okay, these are the two forces only. Try to understand. In this diagram we have only two components. Two components of the force. One is the normal component, another is the tangential component. So normal component is causing a normal translation, and this will cause a tangential translation. Okay. So now another thing is Ig alpha. So Ig alpha is it is due to moment. Now what I am trying to do is, if I can combine this moment here so that there will be only force and no moment. Means you have a force in the normal direction and a force in the tangential direction, and another moment is there. Now I know that by a equivalence force couple system, I can combine that moment and this force to a force only, which can be this force shifted at a later point, so that this force at a later point will accommodate that couple or the moment. So that comes from the equivalence force couple system. As if, try to understand that this couple was there. This couple was there. So if I translate this, force at a distance here, same force at a later distance, later momentum, same force at a later momentum or a larger momentum will create a larger moment. That means this additional moment can be accommodated by this extra momentum, and there will be, if I consider this, that means as if I am adding and subtracting the same force here. Therefore, I will consider this force and this moment. You see, this is the couple. It is in this direction, it is trying to rotate in this direction. Right? Right. So, what is happening? I have just shifted this here, and whatever couple was there, I have accommodated here. Okay. So, what is happening? As if after shifting this force at this point, the couple that was there will be absorbed by the force, because now the force which is shifted at a later distance will be having the same effect as that of the earlier Ig alpha. Okay, so now I will simply consider that couple is already accommodated, because this couple will cancel this couple. This couple will be cancelled by this couple, because I have already taken this. So they will adjust, they will nullify each other, right? Since they will nullify each other, I will have only one force here at a later distance. So initially the force was here, along with that there was a couple. Now since I have shifted the force here, there is no more couple. Couple is no more there, or the moment is no more there. It has been absorbed by the effect of the force which is shifted, and therefore since the force has been shifted at a later distance, extra couple that will be nullifying the couple already was there here. Is it clear? First of all, Is it? Okay. Say for example, say there is a support here. Now you are giving a force here to get the same effect here. This same force, say for example F is there. Now if I shift this force here, what will happen? There will be extra moment because I have changed the length, so extra length increased. Therefore, there will be extra moment. So to have the same effect as earlier, I have to say, for example, there will be extra moment in this direction. So I have to create another extra. I have to create a moment in this direction so that the effect remains same as earlier. So here in this situation, at the later stage, if effect of this force and this couple is same as the effect of this force only. So one force was there, I have shifted that force there, so that force is causing extra couple. So to adjust that, I have to create another couple in the opposite direction, equivalent couple. Now therefore, at a later distance, you have a force and a couple, which is equivalent to a force only at a short distance. So similarly here, you have a force here. Now there is a couple. So if I add this couple with this, it can be shifted at a later distance. That means that extra couple which was there is absorbed by the force and this extra moment arc. Okay. Clear? There will be only force. There will not be any couple. In this case, there will be only force because this extra couple has been accommodated by this extra momentum. I am getting extra momentum. So since I am already that same amount of force, the extra moment that was there earlier, so it is accommodated by this. Although I do not know this distance depends on this moment. As it increases, this will increase. As this decreases, this will be decreasing. Okay. Now we will numerically see what happens. Now we will try to numerically see what happens. Time for the okay. So I know that say about this point. So this I know that this is this. Again about the point fixed point. We had discussed the moment about 3 points. One is fixed point, another is the center of mass, another is an arbitrary point. I can also write m about O fixed point is equal to I bar alpha. I bar means what? The moment IO. IO alpha. IO is the moment of inertia, the axis passing through the moment of inertia about the axis passing through point O. Alpha is same as that alpha. Okay. Now this one. Now for this, therefore, the extra moment. Say if I consider this distance as q. Consider this distance as q. And what is this distance? Sorry, this distance. As earlier we know that this is r bar. This is r bar. So this distance I can take simply r bar. R bar means r bar. R bar means from O to G. Earlier also we have used the same notation. O to G it is r bar. And this distance we are considering as q. Small q. Okay. Now what is this distance? Therefore q minus r. Right? So I can write that q minus r multiplied by this force, that is MAD, magnitude I am taking only. The extra couple is equal to what? Ig alpha, because that has been accommodated by this moment. So Ig alpha. Okay. Now again I know that AT, this AT is equal to R bar alpha. R bar alpha. R alpha. Acceleration in the tangential direction is R alpha. And acceleration in the normal direction is R omega square. Acceleration in the normal direction is R omega square. R bar omega square. Okay. So Ig alpha. Now I can write AT is equal to R alpha. So Q minus R bar. This is R bar. Remember R bar. Q minus R bar multiplied by mass into acceleration, that is R bar alpha, is equal to Ig alpha. Okay. Now again, by using the parallel axis theorem, I can write that Ig alpha IO, by using parallel axis theorem, IO is equal to Ig plus M R bar square. By using parallel axis theorem, I can write this. So Ig is equal to IO minus M R bar square. So it is, now alpha will cancel from the sides. So it will be IO minus M R bar square. And here it is alpha, so it is M R bar Q minus M R bar square. This M R square is cancelled from both the sides. So I can write that IO is equal to M R Q. Right? So that cancels. Okay, that I can write. Again, you see that here only Q is unknown. Q is unknown. Right? Again, I can write from the definition of radius of gyration that IO is equal to K square M. M K square, from the definition of radius of gyration, I can write this. Therefore, I can write that Q is equal to K0 square by R. This is a point from this point to this point. This is a special point. We call this point as the center of percussion. Center of percussion. Okay. This point is called the center of percussion. So, what is the use of this point? It has got very much, say, industrial as well as from the sports point of view, it has got a very much usefulness. So you have seen in a bat. Okay, in a bat you have a point where we call this as a from that we play power stroke or say sweet spot, right? In a bat. So that point, if I strike with that point the ball, then my hand will not feel any tangential reaction. So what is the effect of this? That you see that since all the forces are passing through this point, because this is the component of tangential force and this is the component of normal force. Therefore, through this point, all the resultant, all the external forces are passing. Therefore, you see that if some forces are acting through this point, then there will not be any tangential force which will be acting on my hand or whatever be the bearing. So if you have a bearing, on that bearing there will not be any tangential force. So whatever be the force that is applied, okay, there will not be any tangential force. There will be a normal force, obviously, that is m r omega square, that will be there. But due to this force, there will not be any tangential reaction on my hand. Or say for example racket, say a tennis racket or a bat or a baseball bat, right? Or a hammer, say for example hammer. So when we strike with the hammer, we do not feel any pain because the center of percussion, we strike with the center of percussion. Okay. Say for example, say there is a post. I have to post. I have to set the post in the floor. So if I strike with that, then if I strike to the center of percussion, then I will not feel any pain in my hand, or there will not be any reaction tangential to the that means bearing. That means it will not be lifted. My hand will not be lifted, or my hand will not be shifted. So if I get only normal reaction, then I will be just holding it. But if I get tangential reaction, then it may be lifted. My hand may be lifted, or my hand may be shifted. So that is the usefulness of center of percussion. Okay. Other say industrial applications, like say for example, you want to demolish some building, right? You want to demolish some building with some pendulum. Okay, so large pendulum, large bomb pendulums you have seen. So to destroy the buildings. Now you see that from wherever place it is hold, if that gets reaction, then it may be damaged. So if the pendulum is having a center of percussion and the load is supplied through the center of percussion, then there will be no load on that, no tangential load on the bearing. Okay. Also, there is one application in case of impact testing. Okay, impact testing you will see in mechanical engineering lab, material testing lab. Say there is a pendulum. Okay, the striking of the that means what happens is there is a say metal. Okay, metal rod. I have to break this metal. That is called impact testing. So I have to break this metal by a pendulum. So pendulum, a large pendulum like this. So from one, so it will be lifted from like this, and it will break the metal. Okay. Now once it breaks the metal, there should not be any load on the bearing. There should not be any load on the bearing, tangential load. So if there is a tangential load on the bearing, then it may be broken after certain number of use. So that this strike will be done at the center of percussion. So this will be the center of percussion, and you see that if K0 square is known, R is known, then Q will be known. Okay, so it is fixed to that particular system. Say for example for a bat, or for example a baseball bat, whatever. Okay, thank you. If you have any question, then you can ask. Clear? So we will write two equations: translation and rotation. Then rotation about G or M having a similar relations, and we can solve this. Okay, video off.